Welcome to part 5 on logarithms and graphs. We're working on the last example in this section, and we need to find the domain of f of x equals x times the natural log of 4 minus x squared. We need to graph it in your calculator and use it to find the asymptotes, x and y intercepts, and the local maxes and mins. First, let's figure out what restrictions we have on the guts, or the inside of the natural log. We know that 4 minus x squared must be positive. So let's take the 4 minus x squared and factor it. That means that I'll have x times the natural log of 2 plus x times 2 minus x. Therefore, I will have zeros, or critical points, we'll say, at x equals 2 and x equals negative 2. Now, if you think about it, those would make those two values, 2 and negative 2, would make this natural log undefined, because that is where the zeros of that natural log exist. So what we're going to do is we're going to draw vertical asymptotes at plus or minus 2. Now if I were to graph 4 minus x squared, I would know that 4 minus x squared is a parabola opening downward that's been shifted up 4 units. So before, a normal parabola would be opening something like this. This parabola is opening downward and it's been shifted up 4. So over 1, down 1, and then over 2, down 4. So notice that my parabola, if I were to just sketch it very lightly, my parabola is only positive on the interval from negative 2 to 2. When I sketch that parabola, I can have a visual on where my function is positive and where it is negative. That parabola is positive on the interval from negative 2 to 2, and it is negative everywhere else. So now that I know kind of where my restrictions on the domain exist, I'm going to go ahead and graph this function. I'll go to y equals, I'll enter x times the natural log of 4 minus x squared. And let's see what we get. That is a very interesting graph. Do you see how it only exists on the interval from negative 2 to 2? Maybe not, so let's make our window just a little bit smaller. We know it cannot exist out here because our inputs would be negative for the parabolic region inside the natural log. Now, let's make my x values go from negative 5 to 5, and my y values go from the same, negative 5 to 5. That will allow me to zoom in on the interval a little better. So you can see now that the parabola interval that's positive does some interesting things to the graph. So we have this curve that almost looks cubic. The curve is decreasing as it approaches positive 2 from the left, and it is increasing as it approaches the vertical asymptote at negative 2 from the right. So sketching this function, we get something like this. So now let's find the maxes and mins. We'll do second, calc. We'll do the minimum first. We're asked for a left bound, so we'll go to the left of the low point and we'll hit enter. Then we need to go to the right of the low point and hit enter, and then we guess the low point and hit enter a third time. And my minimum is at negative 1.1, negative 1.1. Let's go to 2 decimal points so that we can see that there's a slight variation in the coordinate point. So negative 1.15, negative 1.13. It looks symmetrical. So let's do second calc maximum to find the high point. So we'll go over to the right side here, but we need to stay to the left of the point we're calculating. So the left side of the maximum we'll say is there, hit enter. Now arrow to the right of the maximum, hit enter, and then guess the maximum, hit enter. And sure enough, we have an interesting symmetry here. The positive coordinate, the maximum, is the same values, but positive, positive now. So we have a coordinate point at our maximum, which is positive 1.15, comma 1.13. If we wanted to find our x-intercepts and our y-intercepts, well, the first one's really easy. We have an x-intercept at 0, 0, which also happens to be our y-intercept. And then we need to find our other two x-intercepts. They will not be the same as these vertical asymptotes. And some of you might be saying, well, yeah, of course it's not. But I just want you to realize that the x-intercepts are not the same as your vertical asymptote values. So we will have an x-intercept on the left side, fairly close to negative 2. So we'll say second calc 0, because it is a 0 of the function. And we'll arrow over and we'll say the left side of the intersection point that's good enough there. Then we'll go to the other side of the x-axis and hit enter again, and then guess the intersection. And we have a 0 at negative 1.73, negative 5.23 times 10 to the negative 13th, which is basically at 0. So we'll say the 0 is at approximately negative 1.70. And the other coordinate point here, that's the 0 of the polynomial, we'll have to do second calc 0, and we'll have to arrow over to the left side of the intersection point, and then to the right side of the intersection point, which is on the other, you cross over from positive to negative, and then guess the intersection point and hit enter again. And again, it's symmetric, so this one is at positive 1.73 and then 5.221 times 10 to the negative 13th. So that's very, very close to 0. So we'll go ahead and calculate that as 1.70. So we have found the asymptotes, the x and y intercepts, and the local max and mins.